All right. I just did a video on questions I anticipate people having from homework 5/6, and I thought I could see the board, so hopefully that's not an issue for anybody. You know, comment in Google Classrooms if you have questions. All right, so now I'm on this page. Hey, do you want to be in it for a second? Come here. Can you tell me what this says? You can stand here for a minute. What does that say?
Cross project.
Product. Cross product. Cross product. What did you say when Mommy was writing it on the board? What does it look like?
Cross product.
No, I know. What did you say about this though? Looks like a what?
Pattern.
A pattern? Yeah, it does look like a pattern. Okay, turn around and wave to the camera.
I can't see myself.
All right, go play quietly. This will be a short video because there's only 2 problems on the page. Okay, so for cross product, this formula looks, I don't know, repetitive, like a lot. I don't have it memorized. I never have my students memorize it. It's always given on an exam. It's more so just knowing what it finds you. And what it finds you is a third vector. So you have 2 vectors already, a third vector that's perpendicular to both of those vectors. So you start with 2 vectors, and those 2 original vectors do not have to be perpendicular. They're not, they could be, they just don't have to be. So you have vectors, let's say vector A and B, okay? This angle is anything, could be 90, doesn't have to be. What the cross product finds you is a third vector that is perpendicular to both. So, it has a right angle with A and a right angle with B, okay? I showed you at the end of the last video how to find a single vector perpendicular to another vector, and that was pretty easy. It was like, we could just there's a ton of options. We could just let either x, y, or z be 0, and then it's pretty easy to create opposites. Besides for those options, there's a ton more options to find a vector perpendicular to another vector, because in a 3-dimensional space, you just have so many options of creating 2 perpendicular vectors. But when we have 2 vectors and we need to find a third one that's perpendicular to both of them, this is where the cross product formula comes in. So they might just ask you straightforward, find U cross product V. Easy, find U cross product V, there's your formula. They might ask you, find a vector that's perpendicular to both U and V. And you need to know that that means cross product. Now, the difference between cross product and dot product is that when you do the dot product, you end up with a number, okay? If, again, the end of that last video, when I did the dot product between U and V on those homeworks, it was a number, -7, I think it was. Here, we're gonna end up with a vector. So you'll note there are commas in the formula and parentheses, meaning that the answer is a vector. Okay, so here's how I would start this. I would start by vector U labeling U1, U2, U3, vector V labeling V1, V2, V3. So then when you go to do the cross product, you just start filling in. Okay, first thing is U2, -1. V3, 6. Minus U3, 2. V2, -5. Comma, I'm making that comma really big just to emphasize. This is gonna be my x value. Next thing, U3. I'll change colors. U3, 2. V1, 4, minus U1, 3, times V3, 6, comma. What I have in green there is going to be the y value of that vector. U1, 3, V2, negative 5, minus U2, negative 1, V1, 4. Okay, then you do the calculations. Just gonna kind of look. You guys calculate while I just look to make sure I plugged in correctly from what I have on my paper. What's up?
What are the guys?
What?
What are the guys on the thing?
4, negative 10,
What are the guys?
negative 11.
What are the guys
What guys?
on your?
Oh, because I said you guys, they're gonna watch the video and they're gonna do the math.
Me?
No,
Which guys?
my students.
I don't see any students.
I know. You can't see them right now. It's okay.
Pretend.
Shh. Gotta pretend. Okay, so what this answer means is that this vector, it's in a three-dimensional space, is perpendicular to that, and that vector is perpendicular to that. So the second question says verify that it's perpendicular to both. Well, how would I verify this is perpendicular to that? It's actually pretty easy. We take the dot product. When I do the dot product of this, 4 times 3 plus negative 10 times negative 1 plus 2 times negative 11. This is the dot product of the cross product in U. I'm getting 12 plus 10 plus negative 22. 22 plus negative 22 is giving me 0. The fact that the dot product is 0 means that these are definitely perpendicular. Find the dot product of those and you'll see that it's perpendicular as well. Okay, so at this point you should be able to do homework 7. Just taking a look. Yeah. I think that one will be fine. Actually I don't. I'm gonna make a comment about number 4. Number 4 on the homework is a parabola. If I was in class and I assigned this homework, I would absolutely be walking around to every student's desk to see what they put for the range for that one. So maybe that's all I'll say about it. When you're doing number 4, think about what you're gonna do for the range. You're gonna give me an exact value. You're not gonna look at this and go, oh, it's about, if you're given the actual function, then finding the range, you should have an exact number there. That's all I'll say about that. And we will regroup soon.